So I wanted to talk a little bit about our different circuits and how they affect the voltage and the current running through them. Now, one of the things I love about electronics is, much like programming, there's a lot of different ways to accomplish the same goal. Now, good example of this, so the first two people to turn this assignment in were Christos and Leah, and I pulled up their two circuits, and they look very different. And I want to explain what's going on in their circuits and why both of them are perfectly valid circuits that work. Now, they do things completely differently. So let's look at Christos's first. So his negative connects to here and goes through here. Now remember, with electricity we can follow it in any direction because we don't know if the electrons are moving or the positively charged particles are moving. So we basically just pick a direction, whatever seems to be easiest for us, and we look at the electricity in that way. So I'm going to pick the negative because it's just the first one I see. It goes to this pin, which connects it to all of these, which thereby connects it to that resistor, and then the push button. At this point, there's no way for electricity to jump from here to be connected to this LED until I push the button down. When I push the button down, this and this are connected, and therefore this whole side and this whole side are connected. When those are connected, the negative continues to move on and goes to the negative pole of my LED. And as those electrons go to the negative pole of my LED, they go out the positive side. Now they're still being attracted by the fact that there's a connection to the positive here. If this connection didn't exist, it wouldn't go through there. But because there's something pulling it, it goes through there and it does work. Those electrons get slowed down a little bit. And then it goes out the positive side and into the negative side. Now that might sound a little weird to you because we've got something going out of the positive side, but that's okay. It's going towards the positive. Those electrons are moving towards the positive side. Now, it goes into this one's negative side and then out the positive side there and then into the positive side of the battery. And so that's how this is working. And when I click the button, both LEDs light up. Now, I want to talk about what's happening here in terms of current and voltage. Now, if we remember current from the document, current is essentially a method or a description of how many particles, electrons, whatever, are flowing through a given boundary point. So if I stick a boundary point right here on the wire or there on the wire or whatever, I'm going to have a amount of current flowing through this wire. Now that current is going to be reduced a little bit when I hit these LEDs because they're going to slow things down a bit. They act a little bit like resistors, and my current's going to slow down a little bit when I go through this resistor. It's like a traffic jam. If you imagine a bunch of cars, let's say we have 100 cars going through, and then they're all going 65 miles an hour. Then they hit the first traffic jam. They slow down, and then they would be stopped here, and traffic would back up forever and never move if we weren't pressing this button. But when we press this button, the traffic goes on through, and it goes through here, and it slows down a little bit here too. And that backup slows the electricity, the current down all the way through the whole circuit. Just like if you have an accident on I-95, 5 miles ahead, it slows it down all the way up, all the way down the road. Same idea. So all this slows down the current a bit, but the electricity goes through, the cars drive on through, and they're all following one very simple path. So that's what's happening with the current. Now the voltage is what is called it's basically our potential energy. We were given the example of something rolling down a hill, the momentum. Once it starts rolling, it's got momentum. It's got the potential energy that is turned into kinetic energy, or in our case, electrical energy. So that is used up slowly along this circuit. Now, this circuit is very different. This circuit, now I can follow the positive or the negative. If I follow the negative, just to keep with what I did there, we'll see the negative connects to the resistor, to here, to the negative pole of my LED. It also follows a similar path to the negative pole of my LED here. And both of those positive poles connect to this left side of our push button. And at this point, no electricity would be flowing unless I press this button. When I press this button, the electrons, the negative energy, moves from this side to this side and goes through the positive. Now here, something very different is happening. What I'm actually doing is I'm dividing my current in half. Half of my cars are going through this path, and half are going through that path. And so when I press this button, yes, everything lights up. This is just as good of a circuit as this one. This is what's called a parallel circuit, because these two things are happening in parallel. This is what's called a series circuit, because things happen one after the other. This one happens after this one. So, okay, that's great, Omar. No one cares. Okay. Oh, I do care. I'm just kidding. All right, so what's happening here is we get half of our cars going through here, half of our cars going through here. Now, some interesting things about parallel circuits is I get half because, well, this is 1 kilo ohm and this is 1 kilo ohm. And since electricity follows that path of least resistance, and they're both the same resistance, electricity flows through both equally. Now imagine these were roads, and one is, let's say, 595, and the other is State Road 84. Now State Road 84 has less room than 595, so it's going to have more resistance. So I'm going to, let's say, increase the resistance of this one while keeping this one the same. What's going to happen here is electricity is no longer going to be evenly divided between the two LEDs. Most of the electricity is going to flow to this one, whereas the rest will flow through here. Now, if you look at my proportion here, I've got one resistance here and two there. What is going to happen when I run the electricity through is 2/3 of the electricity is going to flow through this resistor, and the remaining 1/3 will flow through this one. And we see that happen when I press the button. And this one is significantly dimmer than that one. And we can keep playing with that to see what happens. That's essentially how our potentiometer acts. It's a parallel circuit with resistors on each side, and we are varying this resistance to this resistance, and thereby connecting better to this pin or that pin. So that's essentially what's going on here. Our voltage stays the same, but our current is split in half here.